Hello everyone, let's start our today's session. So I think the others will join during this session. So it is already 4 5 p.m. So I think it is the time to start our session. So it is the very first class in our Geotechnical Engineering to Foundation Engineering, which is conducted by Professor Dilip Kumar Vaidya sir, and I am one of his TA on this course. So today I discuss whatever sir taught in this week uh, one class and briefly discuss it slide by slide, and then we do some assignment problems, previous year assignment problems, which will be helpful to solve the question in exam. So first of all, I introduce myself. So my name is Rajat Boni, and I am one of the PMR research scholar at IIT Exam Dhanbad. I am have 6 month TA experience in Nptel. The subject was ground improvement, which is also conducted by Professor Dilesh Kumar Vaidya sir. So this is my second time as a TA in NPTEL. So in this session, I try to solve and discuss whatever sir taught in this during this week in the class. So please be silent and keep quiet. If any doubts, the doubt session will be conducted at the end of the session, end of my lecture. Uh, if you have any doubts, so then you can discuss in at the end. And during my class, I try to solve the basic. I try to solve the question in basic way and very simple manner, so that you can solve this question and understand this question very easily. Uh, Today I have little bit fever. I am not feeling very well, so please cooperate with me. I am not getting well today, and if one one thing also I am mentioned here, if by chance the network is cut or any technical disturbance occur, don't leave the session. Keep here, and I will be try to rejoin again and solve the problem quickly. So, uh, and during my session, one break will be given at the middle time of our session. That means after 1 hour, the break will be, I think, 5 minutes or 10 minutes. So it will be better for you also and for me also to take breaks during this session. Or it think if we are not getting a break, then it going to monotonous. So let's start our today's session. So again, very well welcome here. So I first discuss the week one lectures very quickly, and in geotechnical engineering 2, which is mostly belongs to foundering engineering. The first week is mostly belongs to the basic soil mechanics. So I think it is very good for us to revisit our concept again in basic soil mechanics, and it will be helpful to you to understand the foundation problems before you go through this basic soil mechanics. So the course is designed so like that it is very comfortable to everyone. So let's start our session, and I am sharing my screen. Please wait. think it is visible to everyone. I think so. Yes. And also my audio is clear. So we start now. So in our very first class, we just discussed the basic soil mechanics. So it is very easy to understand in the first class because it is belongs to our basics in soil. So in first class, we know that the in this week we clear sorry we right. So we discussed the origin of the soil, classification of the soil, wide volume relationship, effective stress, shear strength, and compressibility. So I think all of you go through once in a life this topic. So no need to uh, understandable you in very deeply. So I just read the line one by one, and if anything require which is not understandable to you, you ask, or I think I may discuss here. So here it is said that rock cycle from where the soil is created. So we know that the billions of year ago, I think 4.5 billion year ago, the everything in the earth is in gaseous state. After cooling, it is become molten magma, and further cooling, it is become igneous rock. So our basic rock is igneous rock, from which every rock or soil is created. So in igneous rock, it go through the weathering, so then it is become residual soil. After it go through heat and pressure, it become metamorphic rock. So again, if it is transported or weather again, it is become sedimentary deposit. And if the sedimentary deposit is compacted or cemented, then it is become sedimentary rock. So by this way, the rock cycle is happen, and by weathering and tearing, our soil is created. So it is same thing is discussed here. So the rocks are made from the various type of minerals like quartz, feldspar, like this, and it is minerals has are substance of crystalline from made of from a particular chemical. Then there are three types of rock: igneous rock, sedimentary rock, and metamorphic rock. And these are the type name is given here for different types of rock. Then it is come soil. The action of uh, hello, the action of frost, temperature, gravity, wind, rain, and chemical weathering, the rock may be disintegrated and create the soil particle. So by this way, the soil is created. One thing I am mention here, soil and rock is different. Soil has another type of property, rock has another type of property. But from rock, we can say the soil is created. And also some soil, if it is compacted or cemented, again it will be transferred into rock. So you can see that if in riverside, the flow may occur and water eroded the side of the bank, and it created the many type of soil particle like sand and gravel, silt, clay, like this. Like this, our different type of soil particle is created, and it is very useful to construct uh, for construction purpose for different way. And also, we also understand the behavior of this soil because we want to build our structure in the soil. So soil is a heterogeneous in type nature. So we understand by different theory of this soil particle. Then origin and classification. So soil is classified in three types. One is called transported soil, residual soil, and organic soil. The transported soil is which is transported from one place to another place by wind, which is called alluvial soil, or by water, which is called alluvial soil. Residual soil means the rock is disintegrated in smaller particle, and this particle is reside or keep there only. So this is called the residual soil, and in this it is called laterites and saprolites. Okay. And there is another type of soil which is called organic soil, which is specific name. It is called peat. It is nothing but the disintegrated form of human body or any life related body like leaves, trees like this, and it will become a soil, and it is called peat, which is very good for agriculture purpose. Then again, there is another type which is called engineering soil. And in this engineering soil, we classified in three, which is a coarse grain, fine grain, and sorry, sorry, wait. So, please wait. I think there may be one technical issue, so please keep quiet. Hello, I think it is now okay. So please keep quiet. I again start my presentation. So again, I think it is visible again. So we start again. Hello, I think. Oh, sorry, sorry. Yes, yes. Hello. I think it is visible again, and I am also audible. Hello, hello. Yes, it is clear, and I start my remaining part. I will now again complete it. So, engineering soil has two types: coarse grain soil, fine grain soil. So, coarse grain soil have cohesion less in nature, granular soil, or fine grain soil have cohesive in nature. That means there may be bond between or attraction between two different types of particle. So here in fine soil there exist silt and clay. In clay There are four types of minerals, three types of minerals are present. One is kaolinite, lignite, elite, and montmorillonite. I think everything you study in details, you gone through it in details, so no need to discuss again here. So now one discussion here it is that soil versus other engineering materials. So we know that the other building materials like steel or concrete, it may made or it may make in the presence of expert and also in the factory. So it the quality control may be exist and there may be and we can produce with a desired strength and stiffness. But soil we cannot produce in factory. It is created by disintegration of rocks and some weathering effects like that. So it is created by in nature and it is very heterogeneous in nature. So we can not control the quality of the soil, but we can address many factors by which this soil can be useful to our construction cluster. So then soil is characterized by three in which is called permeability, compressibility, and shear strength. Permeability means the water is passed through the soil void, and compressibility means the volume change or nature of volume change in soil. Shear strength is the strength parameter in soil. Every soil strength is described by the shear strength parameter. So it is very useful to us. Again, field identification of the soil, which is called sand, silt, clay. So sand is defined by in the field by individual particle visible. And some particle are visible, no particle is visible for clay, silt. So like this, so we identify the soil, what type of soil is present in the surroundings, in our surroundings. In the next day, that is class 2, sir is taught about the soil classification. So we know that there may be two types of soil classification. One is for cohesionless soil, another one is for cohesive soil. The cohesionless soil, the most common classification is sieve size analysis. So we uh, analyze the soil by different types of sieves, and which is given by classification is given by IS code. So and pass the soil and then check in what type of dimensions what amount of soil is retained. And by this calculation, we can identify what percentage of soil, what type of soil, what percentages are present in the surrounding. Then the in soil classification, two important in civil analysis, two important term is there. One is coefficient of uniformity and coefficient of curvature. In coefficient of curvature, define the curvature nature of the curve, and coefficient of uniformity define the whether the soil is uniform or not. So, a large coefficient of uniformity corresponded to range in the grain size and the soil are regarded as oil graded, and a coefficient of 1% soil size of the same magnitude. Then the soil coefficient uniformity is less than the 4 for considered as a uniform. And coefficient of curvature is describe the shape of the grain size distribution curve. So, so here for cohesive soil, we use the plasticity chart. It is given by Atterbury. One line is there which is called A line, and there is this line equation is given here, which is called plasticity index is equal to 0.73 into liquid limit minus 20. Liquid limit should be uh, in percentage. I think my health is not good today. I'm trying my best. Uh, then there are different types of tests to find out the liquid limit, plastic limit, and shrinkage limit. So by this way, we understand what type of nature is possess the clay particle or cohesive soil. And here one very important index is called plasticity index, and we find out by liquid limit minus plastic limit, and it is very useful to identify the in what category the clays belong to. Either it is compressive, highly compressible, or highly plastic, or medium, intermediate compressible, like this. And these are the symbol by which I we will represent the soil particle. For gravel, we use G. For sand, we use S. For silt, we use M. Like this way, we identify the soil in a or we define the soil. So, soil classification, steps in soil classification. So, I think these are very monotonous here. We need no need to discuss here. You can go through. It is repetitive in nature if you go through your basic soil mechanics. One thing here it is important. It is a relative density, which is defined by the maximum void ratio minus ratio of the maximum void ratio difference between the ratio of the difference between the maximum void ratio and the natural void ratio to the maximum void ratio minus the uh, minimum void ratio. So you should remember this table, different type of density index based on the relative density. If less than 15% relatively, it is called very loose. Like this, so it is you remember it. It is very useful for you. Then in class 3 of this week, sir discussed about the three-phase diagram. I think in soil mechanics, everyone go through this chapter once in a life, and it is very interesting and very useful for our basic soil mechanics. Understand the basic soil mechanics. So in nature, sorry, my health is not good today. Okay, I again start. So in this three-phase diagram, uh, we know that soil there may be some solid particles of the minerals, and there may be presence water, and also some air bursts present. So all of these we can represent by phase diagram or three-phase diagram, which we generally call. If the dry soil is present, there may be present soil solid, and I have little bit fever today. For starting class, I think it is not good for me. Okay, I tried to my best. So in three-phase diagram in dry soil, uh, the so it is present the soil solid and air. Completely there is no water. In saturated soil, the there is present the water and soil solid only. But in partially saturated soil, we may go through the all types of soil uh, volume like soil solids, water, and yeah. So by different calculation, we find out different parameter of this type of soil three-phase diagram. So in three-phase diagram, in three-phase diagram, there is we found out the void ratio, porosity, and degree of saturation. So void ratio is nothing but the volume of voids by volume of soil. And porosity is nothing but the volume of voids and volume total volume of the solid. So you go through all this formula. It is very interesting. And one thing should be noted that the specific gravity of the soil solid. You uh, clearly understand that I am telling soil solid. So GS, not total soil. The specific gravity of the soil solid of the most of the soil range is between the 2.6 and 2.75. You should remember it. Then there may be some relationship is given. Hello. Huh. I think, wait, there is a problem. Hello. Yes, yes, now okay. So I think my presentation is visible to everyone. If anyone is there, please respond. Uh, there may be some network issue. Hello. Okay, I think it is visible. So again, start with. So here it is given that the different relationship between the soil solids and by the soil solid and by the uh, saturation void ratio like this and unit weight of the water. So here it is the basic formula for to find out the bulk unit weight density. That means for the soil which is called partially saturated. For fully saturated, the S will become 1 and formula is represented like this. And for dry soil, the saturation part will go and the formula is like this. So by this way, we find out the different property of the soil, basic properties. So now we discuss the relationship between the effective stress and the pore water pressure. So we know that the effective stress is equal to the total stress minus pore water pressure. Actually, in practical way, no one can find out the in physical way, no one can find out the effective stress. It is a concept that the stress, which is exactly act at the contact of the soil. So by formula, we found out this, but in physical meaning, there is that is not exist. So we find out the total stress. Also, we find out the water pressure. If we total stress is subtracted from the water pressure, then we get the effective stress. And we subtracted the water pressure because water has buoyancy effect, and it is exact act in upward direction. So it may reduce the total weight of the soil. So that's why we subtracted to get the effective. That means true sense stress which is acting between the soil particle. Then one problem is there which is solved by was solved by Sir in class. Now we come to our last day in this week, day 5. So sorry, fourth class in this week. So here it is discussed about the shear strength parameters. Actually, it is very important, or it is called engineering property for our geotech engineers mostly, because by this property we find out the strength of the soil. and it is govern the stability of the slope, embankment, earth dam, and also govern the bearing capacity of the soil, lateral resistance of the soil, lateral pressure against the retaining wall, like this. So it is very important parameter for us to find out. So the shear strength parameter of the soil may be attributed to three basic components. One is frictional resistance to sliding between the solid particle. One is sorry. One is cohesion and adhesion between the soil particles and the interlocking bridge of the solid particle to resist the deformation. So it is said that it is neither easy nor practical to clearly delineate the effect of this component on the shear strength of the soil. So it is no one can truly understandable or truly find out this behavior nature, and it is our assumption one one of our assumption that in shear strength parameter is attributed in three ways. So So there is the factors or governance factors which is influence the shear strength parameter, which is nothing but change in moisture content, pore pressure, structural disturbance, fluctuation in the groundwater table, groundwater movement, stress history at time. And then also depends on the chemical action and environmental condition. One thing I mentioned here that I quickly go through this because we have to solve. Sorry, we have to solve the previous year assignment problems. So we quickly go through this. If anyone not understand, please ask. I will try to address him or her. So these are the factors is governing the system parameter. And here I is the one formula is given, basic formula, which is mostly given by the Rankine, I think, or maybe the Coulombs, and it is mostly useful formula for find out the uh, shear strength of the soil. That means shear strength tau f is equal to the C cohesion of the soil, also the normal stress of the soil, and multiply this normal stress into the friction coefficient. That is, sorry, 10, 5. Today I really bad fever. I have I try to conclude very quickly, and then one small break is given will be given, and after that I will solve the problems, previous year problems, which is very useful to your exam purpose. So here same formula is written here, and it is written in the effective stress manner. That means we subtract the pore water pressure, and it is given by, I think I already told that it is given by the coulombs. So now also we find out the shear strength parameter by Moore circuit. If you go through the triaxial test or any, I think mostly triaxial test, basic static triaxial test, so you gone through this type of formula, and these are the, if you see in my skin, these are the failure surface or failure envelope on the soil particle. That means soil is failed at an angle of phi, and here it is the minimum stress. It is sigma 1 is maximum stress, and this length is shear stress of the soil. So by this formula we find out the different parameters, sigma 1, sigma 3, phi, which is helpful to find out the shear strength of the soil. Then to find out the shear strength of the soil, there may be conduct 3 4 tests. One is called direct shear test, another is called triaxial, unconfined compression, and main shear test. So this test, I think you go through this type of test in your basic soil mechanics class. Here, sir will discuss is very quickly. So here you show it is shown that the basic setup of the triaxial test, the water pressure, which is confining pressure, and in the vertical direction, uh, apply the derivative stress, and we observe the uh, soil to fail at what angle. So you also see that there is one more cycle, different types of more cycle for different types of pressure. If sigma 1 and sigma 3 change, more cycle dimension also change. And here it is discussed the three types of failure may be observed. One is called pure shear, another one is called barreling effect, and to combination of both, which is called barreling and shear failure. So shear strength, unconfined compression apparatus, we directly find out the shear strength of the cohesive soil. Okay, so this test is very useful to find out the cohesive strength. Then another is Venn shear test, and it is also useful to find out the soft shear strength in the soft situated clay. So it is mostly used to find out the shear strength in sensitive clays. And here one Venn shear setup is given, and we apply the torque. The formula, basic formula of this torque is given here, which is nothing but pi into Cu, which we have to find out Cu into d square is divided by 2 plus d cube by 12, where d square is the diameter of the vein and h is the height of the vein. In week 1, class 5, sir is discuss about the compressibility. In simple word, compressibility is nothing is define the consolidation of the soil. That means volume change of the soil. By this parameter, we find out the volume change nature of the soil. So, so it is said that okay. So it is said that a large wheel or load rolling along the roadway resisting on the clay cause an immediate settlement which is recoverable once the wheel is passed. If the same load is applied permanently, there will be in addition weak consolidation. So please, in few seconds I will back. Please stay here. So, continue our session. So, by this test, like consolidation apparatus, we find out the different compression index, like volume compression index, compressibility index, consolidation index, like this. So here one typical curve is given, which is based on the pressure versus void ratio change. We volume change is directly define the change of void ratio. So here one formula is given for volume compressibility index, which is MV, and which is defined as the A by 1 plus E1, where A is the compressibility index. And by this formula, by using this MV, we also find the total settlement, and which is given by mv into dp, and h is the thickness of the layer, dp is the change in pressure. mv already we discussed in the formula. So we also represent this curve in a straight line by using the log. So it is become the compression index cc, and by this formula we find out the final void ratio. E naught is the natural void ratio, and we'll find it. And here also show the pre-consideration pressure, loading, unloading, all thing you go through. And by this formula, if two types of soil is present, that is pre-consideration and over-consideration soil, by this formula we can easily find out the settlement in the soil. And what is coefficient of compressibility, reloading, CR, coefficient of compression index, and H is the thickness of soil, this is the pre-consideration pressure, and sigma naught is the initial pressure, as del sigma is the changing pressure. By this formula we can easily find out. And one problem also we solve today. And now we come to consideration, and it is different on the time. So clay, we know that the permeability in clay is very less, almost nil. So it is take time to change in volume. So it is defined by with time. So one t, which is called time factor, is determined by which we find out the degree of consolidation. Here it is depends on the thickness of the layer, also consolidation index CV, and time required to consolidate at a particular degree of uh, consolidation. One thing you also mentioned there, if the clay layer is surrounded by two permeable layers, this thickness of the layer is become half, that is 2h become h, but it is one layer is permeable, another is impermeable. We consider the total thickness of the layer. One problem is also solved by the sir in class. You can go through the video lectures of sir. So I think we here one break will be given for 5 to 10 minutes. We will again join to solve our assignment problem, previous year assignment problem. So keep on the meeting, stay on the meeting, and we will meet again after 10 or 5 or 10 minutes. So keep silence or and keep here. Ipinda, thank you.
Hello.
Ah, so welcome back to our session. I will now concluded this. Hello. I think my presentation and audio is visible. So let's start with previous year assignment problems, which is already given at the Nptel site, and I also share you with you to my Google Drive these questions, and also along with the solution, previous year solutions, and you just try to yourself or along with me also you can try. I just one by one discuss this problem, and don't worry about this. All the things I will share with you, and also this call is recorded in my sorry, I have to check. Yes, this call also recorded. Uh, so I will share it with you. So don't no need to worry about it. If any concept you will miss, you can go through the video directly, meeting video directly. So let's start our problem. So in 2020, actually this course was started at 2020. So in 2020, there is one assignment called assignment 0. This is the very basic knowledge question. My health actually is not very well. So I try to conclude it very quickly, even before 2 hours. So please stay on me, stay with the meeting. So in week 2020 week 0 assignment, it is asked that for a soil in natural state, the void ratio is zero point 0.8, water content is 20%, and the specific gravity of the soil solid, remember soil solid, is 2.65, and then what is the degree of saturation of this soil. So we know that, and also Sari discussed in his class uh, when he is going through the three-phase diagram that we know. Uh, yes, we know ES, E mean void ratio, S is degree of saturation, A is equal to G into W, where G is the specific gravity and W is the water content. So all the units should be in points. So uh, water content you have to convert into points, that is 20.2%, 20. And if you uh, uh, given all this data in this equation, you find out that natural degree of saturation is 0.66. I already solved here. You can see here 0.66. So again, then in second, I will share you the solutions along with these questions. So You just try to understand the concept. I will solve one by one. Uh, so then in question two, I think question one is very easy and no need to uh, understand again, no need to go through again. Then question two, it is asked that if the sand is in the denser state, then the relative density of sand is close to which? Denser state means in the extreme state. So in extreme state, densest means superlative degree. So it is all in by its question. It is said that relative density is 100%. So answer is 100%. Then in question three, it is you understand question two. I think denser state means at the extreme state. That means it possesses the 100% density, relative density. Further, further that no density is possible. So in question 3, they say that the water content of the soil which represent the boundary between the plastic state and liquid state. So we know that it is called liquid limit. If you remember that we go through in our class one airline concept for cohesive soil, which is start from 20, and the equation is A is equal to I 0.73 into IP, that is capacity index minus 20. And there is some division, one is at 35%, another one is 55%. I think. So I should check the degree. Please wait. Uh, yes, 50%, sorry. One is at 35%, another one is 50%. So our question is said that the boundary between the this is called sink state or semi-solid solid state. This is called plastic state, and this is called liquid state. The question is asked about the boundary between the plastic state and liquid state. So answer is liquid limit. This line is belongs to liquid limit. So again go back to our questions. So correct answer is liquid limit. Then state the quicksand phenomena. So quicksand phenomena is nothing but when the shear strength is equal to 0 in questionless soil. The questionless soil, we know that C is equal to 0. So tau is equal to sigma dash into 10 phi. If the effective stress or total stress, effective stress is equal to 0, that means total stress is equal to the pore pressure, then the sand is behave like flow condition, like a water. So this correct answer is, so remember this, it is occur when the cohesion is 0, that is pure cohesionless soil. So correct answer is option C, the flow condition occurring in the cohesionless soil. You understand? Okay. I think you will you understand it. Then in question 5, it is said that uh, the soil having particle of nearly the same size in known as, that means we go through the cohesionless soil classification, and one term is we find out that uniformity, coefficient of uniformity, which is nothing but d30 square, sorry, d60 by d10. And if the it is less than for sand, if it is less than I think 4, then it is become uniform soil. This means every soil particle has same size, same dimensions. So it is very, actually it is behave as a poorly graded soil, because if all the soil is uniform, there may be observed large void risk, which is going to very quickly compress when applied load. So our answer is, if the soil having the same nearly same size, it is called uniformly graded soil. Then so it, it will come. So again, start. The sixth question is about the sensitivity of the soil. What is the definition of the sensitivity? Actually, it possesses along with the cohesive soil. So it is said that uh, the ratio of the confined compressive strength of the undisturbed soil to that the soil of the remainder state. So it is mostly happen in the cohesive soil. In cohesive soil, if you collect the soil sample in undisturbed uh, site and you break the soil and again molded it in a specific shape, in first stage it will show the strength is very less. After few times, it will after few times the strength will gradually increase, and this is called remolded state. So, and but it is not gain the same strength as it is before in the undisturbed uh, 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 state. So there may be some gap between undisturbed state and disturbed state. So this ratio of these gaps is called the sensitivity of the soil. How much it is differ from disturbed soil to undisturbed soil in cohesive nature. So correct answer is option B. So in question number 7, it is said that what is the intensity of the active earth pressure at a depth of, sorry, of a depth of 7 meter behind the wall that fell by the sea. My health actually not good today. I tried to very quickly conclude it. So in 7, the question is said that find out the active earth pressure. So before finding out the active earth pressure, we find out the active earth pressure coefficient, that is K is equal to 1 minus sine phi divided by 1 plus sine phi. And the phi is given here is 32 degree. If you put all this value and we get the coefficient of active earth pressure is 0.32. I think I am solving here is 0.31, sorry, 0.31. So after that you apply formula like piezometric pressure. We know that with the increase of depth, pressure is increased linearly. So the equation at 7 degree, so 7 meter, the pressure will be PA, active earth pressure is equal to Ka, active earth pressure coefficient into vertical stress, vertical effective stress. So further vertical effective stress we written here is Ka into gamma dash into H. But here there is no need to subtract. Gamma dash means gamma subgrade submerged bulk density is equal to saturated bulk density minus gamma W. So here I think water, no water is present, so same the gamma dash is equal to Ka is equal to gamma saturated or gamma, whatever is given, because there is no role play in here water. So our formula is become Pa is equal to gamma Ka into H. If you see my screen, I am written. So if you put all this value, you will get the active earth pressure is 39.8. So my also I checked with here. Yes, 39.8. It is correct. Then I will share. No worry. I will share the solutions also along with the question also. You go one by one and try to solve yourself. And if you have doubt, ask me in the next class. I will try to solve again or to go through again. So in question number 8, uh, it is sorry. In question number 8, it is they said that a sample of saturated. Remember, term keywords should be highlighted first. The saturated cohesionless soil is tested in drain triaxial compression. Showed a failure angle or internal friction is 30 degree and deviating stress, the deviating stress at failure for the sample. Find out the defective stress for the confining pressure 20 kPa. So in two ways we can solve this problem with the help of Mohr circle. I think it is very with the help of Mohr circle, and again one formula also given which is very complicated. If you remember it, you can also solve by this problem. I discuss one by one. So it is with Mohr circle. First I drawn here. So first draw a Mohr circle. It is said that quotientless soil. That means C is 0. So the failures envelope we start with origin and touch uh, the Mohr circle, which is which at an angle of 5. Okay, which is given here 30 degree. And if you draw a perpendicular from this line, it will join at the center. So from this to this distance, here it is called sigma 3, that point, and it is called sigma 1. And from center to origin distance is sigma 1 plus sigma 3. My writing is not good. You go through my solution later. You will be understandable again. So then this perpendicular, which is nothing but the shear strength parameter or the radius of the Mohr circle, equal to sigma 1 minus sigma 3 divided by 2. If you put all the values, we know that sin phi is equal to perpendicular by hypotenuse. So here hypotenuse is sigma 1 plus sigma 3 by 2 and perpendicular is sigma 1 by sigma 3. If you put all this value, you will get the sigma 1 value because sigma 3 is here is 200 kPa. After subtract sigma 3 from sigma 1, you will get the confining pressure, which is here is coming about 400. You will also see my solution. If you not understand, I quickly visited my solution. You can see there. Here is the I am drawing here. So it is very simple if you try to draw it with the solve it with the Mohr circle. So no need to remember any typical problem. So you can see that first we find out the sigma 1. Then for finding out the deviating stress, we know that deviating stress is equal to sigma 1 minus sigma 3. Sigma 1 is the major principal stress, sigma 3 is the minor principal stress. This point is sigma 3, this point is sigma 1. So after finding the sigma 1, you will subtract confining pressure, that is sigma 3, you will get 400 kPa. Then in the next question, that is question number 10, sorry 9, it is said that if the volume of wires equal to the volume of solid, if the I think I will teach you in very simple manner. I think everyone is understand what I am going through. So please stay on me, stay with the meeting. And in question number 9, it is said that if the volume of voids equal to the volume of soil solid, okay, then find out the porosity and void ratio. We know that porosity, here it is said volume of void is equal to volume of soil solid. So we know that porosity is equal to volume of void by volume of soil solid. So in both the case, I think uh, VV is equal to VS, so it is equal to 1 porosity. And also we know that void ratio is equal to 1. In porosity we know that volume of void divided by total volume. Here total volume is volume of void plus volume of solid. If you put again this relationship VB is equal to VS, you will get the answer is zero point 0.5. So correct answer is point A, zero point 0.5 and 1. Remember, you should see that which will ask first. Here it is asked first porosity, then void ratio. Our case, I derived the porosity for void ratio first, then porosity. So you should clear carefully go through line by line. Then then it is said that if the time required for 50% last question for week 0 in 2020 assignment, if the time required for 50% consolidation of the sample of clay with a single drainage is 24 hours, uh, then the time required of the consolidation of the same sample, the clay, the same degree but the double drainage. So here for the case, degree of consolidation is equal, so no need to worry. We know that time factor, one formula in consolidation, time factor is equal to the CV coefficient of consolidation into T time divided by H square, depth of the layer, where we find the consolidation. So if all the things CV and T is constant, then we all say that T proportional to H square. If you put T1 by T2 is equal to H1 square by H2 square, and our case we say T1 is equal to 24 hours and H1 is H, because no double layer apply, and where T2 we will find T2, where H2 will be H by 2. So if we put all this value, we will get the answer is 6 hours. So you also go through my solution. I already elaborately discussed here. Go through. I will share you. So then now I try to solve the assignment 1 question in 2020. Remember one thing, that similar type of question also given in the present assignment also. If you try to solve the previous year question or go through once the previous year question solution, you will be able to solve this year question also. Only values are different, but problems are very similar. And you also, for deep knowledge, you also go through one basic soil mechanics book, and you understand more if you read more. So now I try to solve the assignment 1 problem, which is 2020, which is in total is 12 questions. So it is takes time. So I one by one now I try to solve it. So it is very simple. If you study the basic soil mechanics, you easily derive these questions. I will also share the assignment question in 2023, with solution. So you will try by yourself, or if time permits, I will also try one or two problems here. So you go similar type of question here. So no need to worry. So in assignment one, question number one in 2020, it is said that find out the bulk unit weight of the soil, and it is given here the void ratio, specific gravity of soil solid, and unit weight of water. Unit weight of water and water content given for 11%. So please give me a minute. It's feeling very cold. It is very unfortunate for me. In the very beginning class, first class, I have this type of problems, health issue. So please cooperate with me. It is very. I try to solve it is very in very quickly, and before time, I think first day I will leave. And if you have any doubts, you will ask me here. I solve here the assignment one now. So please stay with me. So in assignment one, it is said that find out the bulk unit weight. We know that if you remember in our class, week one, class number three, you find out this formula. Found out this formula that bulk unit weight is equal to GS plus SR into E divided by 1 plus E into whole into gamma W, where G is the specific weight of the soil, S is the saturation, and E is the void ratio. 1 plus E gamma W is the unit flow order. But in our question, the degree of saturation is not given. So you also know that ES is equal to GW. If we replace ES here with the GW, we easily solved our problem because here G also given and water content also given. Remember one thing, water content and degree of saturation is not same. Where water content is here water content is weight of the water divided by weight of the soil solid. But in degree of saturation, it is said that the volume of the water divided by volume of the voids, total volume of the voids. So it is different, two are very different. So don't confuse among these. So now we go back to our questions. So you easily now solve this. If you put all this value instead of SE, you put GW, then you easily find that there is bulk unit weight, and which is here it is 19.62. You can also see my solution that first I found out the SE, I replace SC here with GW and find out that the bulk unit weight is 19.62. Then in question number 2, the same assignment problem is will be given this year also and previous year also. I share with you the previous year questions, so you can go with this and try to solve your spice year, and also try to solve this year question also, which is already in your NPTEL portal. So try to solve it, because if you do not solve here, then the marks will be deducted, and I think assignment marks is given here 40% weightage. So it is very serious for you to solve assignment questions for getting good results. So in question number 2, it is said that a sample of saturated clay has a total mass of soil is uh, 1.5 kg and dry mass is 1 kg. Specific gravity is given here. Find out the porosity of the uh, clay sample. So we know that if you draw the three-phase diagram, sorry, if you draw the three-phase diagram, here it is two-phase because saturated clay. Here it told that saturated clay there is no air bodies remain. So here is void is VW. It is also equal to the VV total void. This phase is called WW, that means weight of water, and this is called weight of solid WS. So here it is given the total weight is, that means WS plus W, that means weight of water is equal to 1.5, and the dry weight, that means WS is given here 1. So if you subtract here 1.5 by 1, you will get 0.5 kg as the weight of water. We know that volume is equal to weight by gamma. That means gamma means unit weight in water. That means BW. Unit weight of water is 1, or sorry, unit weight of water is 9.81, and also specific gravity. Sorry, specific gravity here also is equal to 1. So we find out the volume of water. Then we find out the volume of solid VS, which is equal to the weight of solid Vs Ws divided by the G into gamma W, where G is the specific gravity of the soil solid. If you put, you also get the Vs. But in our case, it is said that find out the porosity. So we know that porosity is equal to the volume of void divided by total volume. So you add Vs plus Vw, get the total volume, because there is no amount of air present. So we will directly get the total volume Vt, and if Vw by Vt, that means porosity, and then we get the in our problem result, that is 0.57. I think it is understand to you. Then in question number 3, it is asked to find void ratio of the soil specimen. Here given it is bulk, water content 15% and bulk unit weight 18.6 kilonewton per meter cube. Unit weight of water it is 9.81 kilonewton per meter cube. G is given 2.65. So if we put all these value, that is bulk unit weight gamma B is equal to G plus SE divided by 1 plus E into gamma W. We know that here no S is given, that is saturation, degree of saturation is not given. If we completely replace the SC by GW, we know that SC is equal to GW. Then all the known things are here. We put and we will get the void ratio, which is zero point 0.6. And also, if you don't understand, also refer my solution. Sorry, yes, solution. You go through it. I already in basic way. I already every source problem I derive here. Then it is said that find out the water content required to fully saturated. So it is said that to find out the degree of void ratio if the sample is fully saturated. If all the data are taken from question number 3. So we know that SE is equal to GW. Find out the water content, not void ratio. So water content, to find out the water content at what water content the soil become fully saturated. So we use this relation from previous. We find out the void ratio. S is equal to here equal to 1 because fully saturated 100%. This implies the 1. And G is previous formula is 2.65. If all the value we put, we get the 23.07. You will remember this result you will get in points. That means 0.2307. You will convert this in percentage by multiplying 100 and write at last in percentage sign. So in question number 5, it is said that, please wait few seconds. So in question number 5, it is said that MCQ type question, rise of water table above the ground surface caused by. So it is said that rise of water table above the ground surface is caused by increase in both pore water pressure and total stress, because we know that total stress is equal to effective stress plus pore water pressure. In our case, in all the form, effective stress is constant. So if that means increase of total stress, which is depend on this increase of pore water pressure. So if you increasing on gradually the upper water pressure automatically increase the total stress, and at one time the rise of water table become above the ground surface because to increasing the water pressure. So I think it is understand to you. Then question number 6. It is given that a questionless soil has a maximum void ratio is 0.85, minimum void ratio is 0.5. In the field, the soil compacted at a unit weight of 18 kilonewton per meter cube. At a water content is 18%. Relative density find out, and also assume that gamma W is 10 and GS is 2.7. So it is very easy. We actually find out the natural void ratio, which is using by this formula. We also solve one problem here. That is G plus SC by 1 plus E into gamma W. If we replace the SC with GW, you will and put all this value, you will get the void ratio. After finding the void ratio, if you put relative density formula, that is E max minus natural void ratio divided by E max minus E minimum, maximum void ratio and minimum void ratio. Put all this value and you will get the 65.71%. Then a soil sample has a compression index, that means CC, is given zero point 0.3. The void ratio pressure at a pressure of intensity 15 degree is given 15 kilonewton per meter square is zero point 0.5. So find out the final void ratio increase the pressure to 25 degree. So we know that CC means compression index. When we convert the void ratio versus uh, stress curve into log scale, then this slope is called compression index. If you remember in compressibility class. So we know that change in void ratio divided by the log 10 base 10 sigma 2 minus sigma 1 is equal to compression index CC. And put all this value and we will find the change in void ratio first. After that, this slope is negative slope. So final void ratio is greater than the less than the initial void ratio. So you subtract this change in void ratio from initial void ratio and get the final void ratio, and which will be 0.43. In question number 8, it is said that confining pressure is given for situated questionless soil, and also given the dielectric stress. So find out the resistance failure angle, that is shear resistance angle. Hi. So we already discussed this type of problem, and it is very to solve with the Morse circle. If you draw the Morse circle here, this one is sigma 3, this one is sigma 1, And this, if it's quotientless, this line is tangential of the north circle, and this angle is called phi. And this normal is called sigma 1 minus sigma 3. And here it is given sigma 3, sigma 1 minus sigma 3. So first we find out the sigma 1, because which is called sigma, find out by these two, using these two equation, and it is given about 400 something. And after that, using this formula, that is sine phi is equal to 1, sorry, sigma 1 minus sigma 3 divided by sigma 1 plus sigma 2. If we put all this value, get the sine phi. We inverse the sine phi, we will get the degree of phi in radian, which is, or we can say, if we converted this, you will get phi in dB, which is coming about 19.47. In question number 9, we find out the settlement, total consolidation settlement, del H. We know that del H divided by H, thickness of strata, is equal to the change in void ratio del E plus 1 by 1 plus initial void ratio. I think all the values are given here. You put, you will get the answer of total settlement is about 0.408 in meter. Then in question number 10, it is asked to find out the total stress. All the condition is given. That means a sand layer is present under the 20-meter water depth. That means water depth is 20-meter. A sand layer is present. Water here is sand. 20-meter water depth. And degree of saturated unit of the sand is given 19.5. Specific gravity of soil is given 2.65, and specific gravity of water is given 1.03. Unit weight of fresh water is given 9.81. Total state at the depth of 25 meter below the sea floor. That means from the sea floor, I can go 25 meter. So we know that total stress is equal to this layer stress, total stress, and this layer total stress. For this layer, there is only present water, which is 20 into 1.03 into 9.81, because here pure fresh water is not used. Here it is seawater use, and specific gravity of seawater is 1.03. So we have to multiply it. And for this layer, total stress is strength, it is 25 into 19.5 plus 1.03 into 25 into 9.82, because water is seeped through this sand layer. And if you add both, we will get the total stress is about 689.5 kPa. That means kilonewton per meter square. So, an 11 question is the extension of this question number 10. Here we have to find out the pore water pressure. It is very simple. Only add the water pressure which is present both the layer. No need to add the pressure which is given by the sand. So The unit of water is 20 plus 25. In both the case, the water is same into 1.03 specific weight of water into 9.81 fresh water unit weight. If you work with, you will get 400 454.5. Last question is our assignment problem. Also in our session, sorry. So you don't need worry because I will send everything, also video recording. So the effective stress, effective said that effective stress shear strength parameter for soil are given is equal to uh, 15 kilonewton per meter square, and phi is given is 30 degree. So if and then shear strength, we find out the shear strength, that is tau. If normal stress given and pore water pressure given. So for this we use the Coulomb formula, that is tau is equal to C dash, sorry, my writing is not good here. Yes, C dash plus sigma dash 10 phi, phi dash, sorry. So in all the cases we use the effective parameter, just effective stress parameter. I think please everyone silent your or mute your meeting. I will getting disturbed here. Please mute your. So tau is equal to, that is shear strength. We have to find out the shear strength. Here effective stress, to find out effective stress, we say that total stress minus unit pore water pressure. So if you put 200 to 10 minus 85, which is pore water pressure, we will get the effective stress. After all, after that, if we put all these parameter here, C, that is 15 kilometer meter square, phi is 30 degree, and sigma dash is about total stress meter, pore water pressure. And put all this value, you will get the strength. Shear strength is, effective shear strength is about 87.17 kPa. That means kilometer per meter square. So I think we will stop here. We discuss here today the previous year assignment question 2020, and I also share the this year, 2023 assignment question. Also, my health is not good today, so I think what I am discussing here, everyone should understand or able to understand this, and I will share with you the previous year assignment problems. You will try to solve by yourself, or we can help. Sorry, you can go through with my solution if you not understand it, and try to solve this year question which is already given at the Nptel portal. And similar type of problems is there, only numerical value was changed. And if you go through this question in previous this year, you will find that this is question is very easy, and we will build the confidence to solve the next assignment. And also it is very important for your exam purpose, which is conducted by NPTEL, and this weightage, also good amount of weightage also given in assignment, so don't miss it. And I will share today's class lectures, also video with you, and I whatever I am discussing here, solution, previous year 2020 solution, also the 2023 solution, you go through once and try to solve by yourself this year assignment problem. So for now, I leaving the meeting. I also having some headache and fever, so it is not possible to continue further. So I think I stop here. So we will meet again in the next class, that is week 2, and also try to solve the questions, previous year questions, and also I try to frame the some question by myself and given some example also. So please go through it. So stop now. I closing my meeting.